How did ancient civilizations create technology that still puzzles us today? It's a fascinating question, isn't it? We often view the past through a lens of simplicity, a world without circuit boards or satellites. But scattered across history are artifacts and structures so advanced they challenge our entire perception of what ancient people knew. These aren't just curiosities, they are feats of engineering and science that, in some cases, we are only just beginning to understand. Today, let's unravel the mysteries behind 10 ancient inventions that were centuries ahead of their time. Off the coast of the Greek island of Antikythera, in the year 1901, divers exploring a Roman-era shipwreck found something extraordinary. Amidst the statues, pottery, a lump of corroded bronze. For decades, it was thought to be a rock or piece of statue. Then, X-rays in the 1970s revealed its true nature, the Antikythera mechanism, an astronomical calculator of breathtaking complexity, often called the world's first analog computer. A shoebox-sized device packed with at least 30 interlocking bronze gears. Turning a hand crank could predict the position of the Sun, Moon, Mercury, Venus, Mars, Jupiter, Saturn. It could forecast eclipses with remarkable accuracy. It even tracked the 4-year cycle of the ancient Olympic Games. The Roman Empire left behind structures that have endured for 2 millennia: the Pantheon, the Colosseum, aqueducts that still stand tall. Part of their secret lies in their concrete, or opus caementitium. For a long time, we thought its longevity was simply due to a good recipe using volcanic ash, or pozzolana. But recent discoveries have revealed something far more clever. Scientists noticed small, white chunks of lime called lime clasts distributed throughout the concrete. For years, these were dismissed as evidence of poor mixing or low-quality raw materials. These lime clasts are the key to the concrete's incredible self-healing properties. When a tiny crack forms in the concrete and water seeps in, it reacts with these pockets of lime. This reaction creates a calcium carbonate solution that quickly recrystallizes and fills the crack, effectively healing the damage before it can spread. Even more impressively, Roman seawalls and harbor structures made with this concrete actually grew stronger over time as they reacted with the minerals in seawater. We are only now learning how to replicate this ancient, sustainable technology. In 1938, near Baghdad, a strange artifact was unearthed. It was a terracotta pot, about 13 centimeters high, containing a copper cylinder. Inside that cylinder was an iron rod, held in place by an asphalt plug. Put together, it looks uncannily like a galvanic cell, a simple battery. If you were to fill this jar with an acidic liquid, like vinegar or grape juice, the combination of copper, iron, and an electrolyte would produce a small but measurable electric current, somewhere around 1 volt. The immediate and controversial question is, what was it for? The tales of Damascus steel are honestly the stuff of legend. Blades forged from this metal were said to be so sharp they could slice through a falling silk scarf, and so strong and flexible they could be bent 90 degrees without breaking. The steel was produced in the Near East from ingots of wood steel imported from India, Sri Lanka. These ingots contained a unique mix of elements and a high carbon content. The problem is, sometime around the 18th century, the knowledge of how to produce this incredible metal was lost. Modern metallurgists have tried for decades to reverse engineer it. Using scanning electron microscopes, they've discovered that the properties of Damascus steel come from carbon nanotubes, cementite nanowires, a level of nanotechnology the original smiths couldn't possibly have seen, but clearly knew how to manipulate. Imagine being a sailor in the 7th century, your wooden ship under attack. Suddenly, the enemy vessel unleashes a stream of liquid fire that clings to your ship, your sails, and even the water itself. This terrifying weapon was Greek fire, the secret weapon of the Byzantine Empire. It was typically deployed using a siphon, a large bronze tube mounted on the bow of a ship operated by a pump. This system acted like a flamethrower, projecting the burning liquid onto enemy ships from a safe distance. The primary ingredients were likely crude oil, naphtha, pine resin, calcium phosphide, sulfur, quicklime. The quicklime, when it hit water, would generate immense heat, and the calcium phosphide would produce a gas that spontaneously ignites on contact with air. But the exact recipe, the proportions, and the method of pressurization are unknown. A military secret so well kept that it vanished from history. This terrifying weapon was Greek fire, the secret weapon of the Byzantine Empire. This one is more theory than proven fact, but it's a fascinating one. We've all heard stories about ancient builders moving colossal stones, and we usually assume it involved brute force, ramps, rollers, thousands of workers. But some researchers have proposed a more elegant, if speculative, solution: acoustics. Temples and chambers, like the Hypogeum of Hal Saflieni in Malta, seem to be designed as giant resonance instruments. Certain frequencies spoken or chanted within these chambers are amplified dramatically, creating powerful physical vibrations. The idea revolves around the possibility that ancient cultures understood and could manipulate the physical properties of sound waves. Specifically, the concept of acoustic levitation, where powerful sound waves are used to counteract the force of gravity. While levitating multi-ton blocks with sound remains firmly in the realm of science fiction for us today, the acoustic properties of some ancient sites are undeniably remarkable. The theory suggests that perhaps this wasn't just for ceremonial purposes, but a practical application of physics, using focused sound and vibration to reduce the friction of massive stones, making them easier to move. In the bone-dry Nazca Desert of southern Peru, same region famous for those giant geoglyphs, there's another practical marvel: the Puquios. Puquios, a vast network of underground aqueducts built by the Nazca people over 1,500 years ago. Many are still in use today, providing water to a region that gets almost no rainfall. The system taps subterranean aquifers high in the mountains and channels water through underground canals for miles across the desert, delivering it for drinking and agriculture. What makes them ingenious are the spiral-shaped holes that dot the landscape. They're called ojos, or eyes. Wind blowing across the desert into the spirals forces air through the underground channels that airflow keeps water from stagnating and actually pushes the water forward through subtly graded tunnels. A brilliant passive hydraulic system, keeping communities alive in an extremely arid place for centuries. When we think of the Indus Valley civilization, which flourished around 2500 BC in what is now Pakistan and India, we usually picture well-planned cities, Mohenjo-Daro, Harappa. But among the ruins, archaeologists have discovered smaller objects that hint at a surprisingly sophisticated understanding of physics. These include a variety of toys, what might be tools, but most notably, small terracotta tops. These are not just simple spinning toys. Some have remarkably precise designs with pointed tips, all optimized for a long, stable spin. They demonstrate a practical understanding of concepts like angular momentum, center of gravity. Even more intriguing are certain bronze objects that bear a striking resemblance to aerofoils, objects that resemble propeller blades. Their exact purpose is unknown. They could be decorative, ceremonial, parts of a larger unknown machine, but their shape is undeniably aerodynamic. The desire to keep our possessions safe is as old as possessions themselves, and in ancient Egypt around 4,000 years ago, they developed a solution that is conceptually identical to the locks on most of our front doors today. I'm talking about the Egyptian pin tumbler lock. The design was simple but incredibly effective. It consisted of a wooden bolt that secured the door, which had a slot on its upper surface. Inside the slot were several vertical holes filled with wooden pins of varying lengths. A hollow in the doorframe above held a matching set of pins that would drop down by gravity into the holes in the bolt, locking it in place. The Egyptian key was a large wooden toothbrush-shaped object with pegs on its end that matched the pattern and length of the pins inside the lock. When the key was inserted into the bolt and lifted, its pegs would push the pins up to a uniform height, clearing the shear line and allowing the bolt to be slid open. This is the exact same principle, using a key to align pins at a shear line, that Linus Yale Jr. patented in the 1860s. The Egyptians had figured out the core concept of modern mechanical security 2 millennia before the Roman Empire even existed. These small, often overlooked artifacts are a testament to advanced Bronze Age design and engineering thousands of years before these principles were formally codified. Moving water, especially uphill, has been one of humanity's greatest challenges. Long before electric pumps, ancient civilizations devised brilliantly simple machines to do the job. In Egypt, we see the shadoof, a device that appeared as early as 2000 BC. It's basically a long pole balanced on a fulcrum, with a heavy counterweight on one end and a bucket on the other. A single operator could lower the bucket into the Nile, let it fill, then the counterweight would lift the water up to the irrigation canals. It revolutionized agriculture along the Nile. A few centuries later in Greece, the Archimedes screw appears, attributed to Archimedes in the 3rd century BC. It consists of a large screw or helix inside a hollow cylinder. Turn a crank at the top, the blades scoop up water from below, carry it up the cylinder, and discharge it at the top. It was incredibly efficient for its time, powered by hand, by windmill, or people walking on the casing. Both the shadoof and the Archimedes screw are perfect examples of appropriate technology. Simple, effective, so well designed they're still used in some parts of the world today. From mechanical computers to self-healing concrete, the ingenuity of our ancestors is truly humbling. These inventions aren't just historical curiosities, they're echoes of a lost knowledge, reminders that the path of technological progress is not always a straight line. They challenge us to ask what else we might have forgotten and what other marvels might still be buried, just waiting to be rediscovered. As we continue to study these objects with our modern tools, we're not just learning about the past, we're learning new ways to build a better future, inspired by ancient wisdom. Which ancient invention do you find most mysterious? Let me know in the comments below. If you enjoyed this journey into the mind-bending innovations of the past, please consider giving this video a like and subscribe for more. Thanks for watching. This exploration of lost and forgotten technology is just the beginning.